Dr. DeGray, you talk about aging and explain it's a disease. Most people think it's just a part of life or the end of life. Can you explain the difference there?
Well, I don't exactly call aging a disease, first of all. Whether you call aging a disease or not depends on your definition of the word disease, and people have different definitions. What I do say, however, is that aging is a legitimate and foreseeable target for medical intervention, because what aging actually is the collection of early stages of all of the diseases of old age. So the collection of precursors of those diseases, if you like. The reason why a disease is a disease of old age that doesn't affect young adults is simply because it is some aspect of the later stages of something that goes on throughout life, and that is aging. Aging can be described in another way as the accumulation of molecular and cellular damage in the body. Damage which is caused as simple side effects of the body's normal operation, and which the body is set up to tolerate a certain amount of, which is why aging is basically harmless until middle age or a little older. But eventually the amount of damage exceeds the threshold that our body is set up to tolerate, and that's when the diseases and disabilities of old age emerge. So what that means is that treating aging is not a science fiction concept at all. It's absolutely simply preventative geriatrics, preventative medicine for the diseases and disabilities of old age.
In a simple form, how do we do that? How do we treat aging then?
At the moment, the problem is that aging is really complicated. There's lots of things that go on throughout life, and they lead to a vast number of different disabilities and diseases, of course, late in life. So the question is, how can we actually tackle this? And at the moment, the short answer is we can't. At the moment, the simple interventions that we have, supplements, dietary regimes and so on, can only do a very small amount to postpone the ill health of old age. Unless, of course, you're somehow unlucky, you're aging in some way at a particularly rapid rate, and then there are things we can do that can somewhat normalize that rate. But if you're already normal, or better than normal, if you're doing well for your age, then the things that are available today, there's no evidence that we can really do anything at all. So that's why we need therapies that don't yet exist, and that's what Sense Research Foundation works on. We're working on developing medicines that really will tackle aging properly. And here's the big thing. We're interested in medicines that don't merely slow down the clock of aging, the accumulation of this damage. They actually repair the damage, so they genuinely rejuvenate people. We will be able to take people who are already in middle age or older and actually fix them up so that they don't only look but also feel and function exactly like a young adult as a result of these therapies. And of course that sort of therapy can be applied periodically, so there's no reason for any limit on how long one can stay truly youthful when these therapies exist. I don't think they're all that far away. I think that we have at least a 50-50 chance of developing truly comprehensive rejuvenation medicine of this sort within the next 20 or 25 years. All it really needs is for us to get on and do the really critical proof of concept biomedical research that Sense Foundation is pursuing and other people are pursuing as well in certain cases, and to get that to happen as soon as possible. At the moment, I can't deny that it could be going a lot faster if there were more resources attached to this. In other words, if people understood what I've just been telling you about aging being something that can be, in principle, postponed and reversed by medical intervention.
What are some of the potential therapies that you're talking about that can rejuvenate the different body parts?
We're really talking here about regenerative medicine in a broad sense. So regenerative medicine means, of course, stem cell therapies, which replace cells that have not been automatically replaced when they die. Normally, of course, cells are replaced by the division of other cells. That sometimes doesn't happen. Parkinson's disease is a fine example of a disease of aging that's caused by the loss of cells in a particular part of the brain. There are stem cell therapies in clinical trials already for addressing Parkinson's disease, and they're at an early stage. Sometimes they work, sometimes they don't, but when they do, they work spectacularly. So this is undoubtedly going to be the way that Parkinson's disease is cured in the future. Regenerative medicine also includes tissue engineering, creation of artificial organs in the lab that can then be transplanted into the body to replace a diseased organ, an aged organ maybe, just as if the new organ had come from a donor. This is going to be a big part of regenerative medicine as well. But beyond that, there are aspects of regenerative medicine that don't get nearly so much airtime and that are really at an earlier stage of development, but which will be very relevant to the treatment of aging. One is the removal of cells when you've got too many of a particular type of cell. That happens, of course, in cancer when cells divide when they're not supposed to. It also happens in the immune system and other places where cells don't die when they are supposed to, so they accumulate. And then finally, there's a really important family of categories of molecular regenerative medicine, where instead of replacing a whole organ or replacing the cells within an organ, we actually repair the cells. We actually go into the cells and restore their internal structure by removing molecular garbage that they haven't been able to digest, for example. And that can also happen in the spaces between cells, what we call the extracellular space. Then there's things like hypertension, which are caused by the stiffening of the extracellular lattice of proteins called the extracellular matrix. This matrix has to be elastic, and it gets that elasticity from the way it's put together, the way the proteins that it's made up of are linked. There are additional links that form spontaneously throughout life as a result of chemical reactions with sugar, and we need to get rid of those links. So all of these things are being pursued aggressively by Sense Research Foundation and by other organizations, and the more aggressively we pursue them, the sooner those therapies will come along.